Question 7. So let's start off first of all. Let's think. So sec, that's 1 over cos. So let's get busy with this. So we've got 4 sine x equals 1 over cos x. Okay, multiply both sides by that cos x. I don't like it being there. And let's see what happens. Equals 1. Now, what you should be recognizing at this point is you should remember that sine 2a, remember in your double angle formulae, 2 sine a cos a. All right, we need to use that. All right, now what you should be doing is if you get something you think, oh, I don't really know what to do here, all right, try and remember some identities, think about double angle formulae and try and go from there. Right, so if we use this, then we should then be able to write down 2 sine 2x equals 1. Divide both sides by 2, of course. This inverse sine, and we get 2x is equal to, so we're working in radians, pi over 6. Now remember here, just think about how many solutions that we might possibly have. It tells me to solve between 0 and pi over 2. So just have a little think about sine, and what we should be thinking about sine, as we know it goes like this. Whenever you're not sure, just draw something out. It does make life a lot easier. And we've got, just want to kind of have a little think about this other point over here. So we've got pi over 6, but also just consider, what about if we've got, let's say, 5 pi over 6 as well. So now if we've got 2x is equal to that. So if we divide both of these by 2, pi over 12, divide this one by 2, and actually, look, it is less than half pi. So very easy to miss that particular solution out. All right, be really careful about that. Right, okay, so on the second one. Okay, so this is, I'm looking at this. This is shouting at me our addition formula. So let's make some sense of what we've got here. So let me just write down the question again for you. So we've got 5 sine theta, take away 5 cos theta equal to 2. Right, let me write down what's important. So we should be familiar with this. So I suppose at half the battle is just kind of recognizing that you know, this is like the best approach, as is in, you know, most questions where you get stuck. It's thinking, right, what's going to be the best way forward on this question? Okay, so have a look and think about this. What I'm trying to do is I've got something in this form here. I've got something in this form, and the R addition formula talks about rewriting it like this, just here. So let's now focus on this bit here, sine theta minus alpha there. So if I rewrite that part there, we get this. And again, all I'm using, just using my addition rules, which are in the book, so in your formulae book. So that gives us sine theta cos alpha. So obviously if you can't remember, just go and have a look in the book, because it is there. There we go. And sine alpha. Right. Okay, so what's a good idea here is just to write this next to it. And then what we're going to do is we just equate the coefficients. That's all we're going to do. And it's just like one of those questions. You just have to kind of keep doing them, really. And then, you know, you remember. So look at this. When I multiply this bit out, I get r sine theta cos theta. So it's the same as this. I've got sine theta. 5. So 5 must equal r times cos alpha. So that's what we're going to write down. So we got r cos alpha must equal 5. Now I'm going to do the same here, do exactly the same. So I've got the sine, got the r, must equal 5. So I can write r sine alpha must also equal 5. Now, what do you get if you do this? Divide this. If I write r sine over r cos, that's equal to 5 over 5. Wait a minute, sine over cos, that's tan. The r's are going to cancel. So tan alpha must equal 1. So therefore, inverse tan, 45, right? So that bit there's got to be 45, right? So that's really important. Right? We'll come back to that in just a second. Now let's think about what r is. And again, using this bit of knowledge up here, and it's all to do with sine squared cos squared. So if you think about, we know that sine squared times plus cos squared is equal to 1. So if you think about squaring this one and plus the square of this, so let's just see where we end up here. So we've got sine alpha. So if I square that, and if I add the other one squared, so got cos alpha, oops, all the way around, whoops, sorry. And then what we've got, so what would this actually end up being? Well, obviously I've got the numbers, so I've got 5 squared plus 5 squared, so that's going to equal 50, okay, 25 plus 25. Now, what will this be? Wait a minute, sine squared plus cos squared is 1, so r is a common factor, so in fact that's just going to be r. So r squared. So r squared must equal 50. So r is root 50. Now let's just piece together the information that we've got. We've got this, we've got this. Let's just go back up to what we had originally. So just write this bit out again, but with our knowledge. So we know we've got, so r is root 50, and then we're going to multiply that by sine theta minus 45, and we know it's equal to 2. There we are. So divide both sides by root 50. Here we go. Over root 50. Inverse sine both sides. So theta minus 45. So that's going to equal 16.4. Now I'm not sure again how many solutions I'm going to need here, so I'm just going to write down next one. Sometimes it's worth writing a few down. And let's again just think about maybe a curve, think about what's going on. We want all the solutions from 0 to 360. Again, it's always worth just having sine there. So yeah, it's just going to be the 2 there, isn't it? So if we need to work out theta, it's just going to be these add 45. So we can have 61.4 and 208.6. If you wanted to work out, like the next one would just be over there, but then you would be adding 45 to it. So obviously it's not going to make sense, is it? So it's going to be outside our range. There we are, done.